Welcome to the channel NextGen Tech Prep. In today's video, we are diving deep into essential questions and comprehensive answers for the Google Professional Cloud Security Engineer certification. Whether you're preparing for an exam or just looking to sharpen your knowledge, you're in the right place. If you find this content valuable, please hit that subscribe button and ring the notification bell so you never miss an update. Now, let's get started.
Your organization is migrating business-critical applications to Google Cloud across multiple projects. You only have the required IAM permission at the Google Cloud organization level. You want to grant project access to support engineers from two partner organizations using their existing identity provider, IDP, credentials. What should you do? The options are: Option A, create two single sign-on, SSO, profiles for the internal and partner IDPs by using SSO for cloud identity. Option B, create users manually by using the Google Cloud Console. Assign the users to groups. Option C, create two workforce identity pools for the partner IDPs. Option D, sync user identities from their existing IDPs to cloud identity by using Google Cloud Directory Sync, GCDS.
To arrive at the correct answer, we focus on the keywords: grant project access to support engineers from two partner organizations, using their existing identity provider, IDP, credentials.
The correct answer is option C, create two workforce identity pools for the partner IDPs.
Why is this correct? C. Workforce Identity Federation enables granting access to Google Cloud resources using external identities from partner organizations directly, without needing to sync directories or create local users. Why are the others incorrect? A. Single sign-on for cloud identity requires user identities to already be managed or synced in cloud identity, which is unsuitable for external partner directories. B. Manually creating users is unscalable, creates administrative overhead, and fails to leverage the partner's existing IDP credentials for authentication. D. Google Cloud Directory Sync requires synchronizing partner directories with cloud identity, which is complex and often restricted by partner security policies.
You are creating a secure network architecture. You must fully isolate development and production environments, and prevent any network traffic between the two environments. The network team requires that there is only one central entry point to the cloud network from the on-premises environment. What should you do? The options are: Option A, create one virtual private cloud, VPC, network per environment. Add the on-premises entry point to the production VPC. Peer the VPCs with each other and create firewall rules to prevent traffic. Option B, create one shared virtual private cloud, VPC, network and use it as the entry point to the cloud network. Create separate subnets per environment. Create firewall rules to prevent traffic. Option C, create one virtual private cloud, VPC, network per environment. Create a VPC Service Controls perimeter per environment and add one environment VPC to each. Option D, create one virtual private cloud, VPC, network per environment. Create one additional VPC for the entry point to the cloud network. Peer the entry point VPC with the environment VPCs.
To arrive at the correct answer, we focus on the keywords: fully isolate development and production environments, prevent any network traffic between the two environments, only one central entry point to the cloud network from the on-premises environment.
The correct answer is option D, create one virtual private cloud, VPC, network per environment. Create one additional VPC for the entry point to the cloud network. Peer the entry point VPC with the environment VPCs.
Why is this correct? D. Creating a separate VPC per environment ensures full isolation. Using a central entry point VPC, hub, peered to environment VPCs, spokes, fulfills the single entry point requirement while preventing direct traffic between spoke VPCs because VPC peering is not transitive. Why are the others incorrect? A. Pairing the development and production VPCs directly contradicts the requirement to fully isolate them. Also, adding the entry point to the production VPC fails to create an independent centralized entry point. B. A single shared VPC does not fully isolate environments at the network level since they share the same routing domain. Relying solely on firewall rules is less robust than using separate VPCs for full network isolation. Why are the others incorrect? C. This approach lacks a central entry point from the on-premises environment. Additionally, VPC service controls are designed to mitigate data exfiltration risks for Google Cloud APIs, not to manage general VPC to VPC or on-premises connectivity.
You work for a large organization that is using Cloud Identity as the identity provider, IDP, on Google Cloud. Your InfoSEC team has mandated the enforcement of a strong password with a length between 12 and 16 characters for all users. After configuring this requirement, users are still able to access the Google Cloud Console with passwords that are less than 12 characters. You need to fix this problem within the admin console. What should you do? The options are: Option A, review each user's password configuration and reset existing passwords. Option B, review the organization password management setting and select Enforce Password Policy at the next sign-in. Option C, review each user's password configuration and select Enforce Strong Password. Option D, review the organization password management setting and select Enforce Strong Password.
To arrive at the correct answer, we focus on the keywords: Cloud Identity, enforcement of a strong password, users are still able to access, admin console.
The correct answer is option B, review the organization password management setting and select Enforce Password Policy at the next sign-in.
Why is this correct? B. When a new password policy is configured in Cloud Identity, existing passwords are not immediately invalidated. Enforcing the policy at the next sign-in ensures all users update their non-compliant passwords. Why are the others incorrect? A. Manually resetting existing passwords for every user is inefficient, disruptive, and unmanageable at scale for a large organization. C. Password policies and enforcement settings are configured at the organizational unit, OU, or group level, not individually per user. D. Configuring the strong password setting only applies when passwords are created or changed. It does not force users with existing weak passwords to update them immediately.
Your organization is preparing to build business services in Google Cloud for the first time. You must determine where to apply appropriate controls or policies. You must also identify what aspects of your cloud deployment are managed by Google. What should you do? The options are: Option A, model your deployment on the Google Enterprise Foundation's blueprint. Follow the blueprint exactly and rely on the blueprint to maintain the posture necessary for your business. Option B, use the Risk Manager tool in the Risk Protection Program to generate a report on your cloud security posture. Obtain cyber insurance coverage. Option C, subscribe to the Google Cloud release notes to keep up on product updates and when new services are available. Evaluate new services for appropriate use before enabling their API. Option D, study the shared responsibilities model. Depending on your business scenario, you might need to consider your responsibilities based on the location of your business offices, your customers, and your data.
To arrive at the correct answer, we focus on the keywords: determine where to apply appropriate controls or policies, identify what aspects of your cloud deployment are managed by Google.
The correct answer is option D, study the shared responsibilities model. Depending on your business scenario, you might need to consider your responsibilities based on the location of your business offices, your customers, and your data.
Why is this correct? D. The shared responsibility model defines exactly which security controls Google manages, e.g., infrastructure, and which the customer must handle, e.g., data, access, fulfilling the core requirements. Why are the others incorrect? A. The blueprint is a great starting point, but relying on it exactly without actively understanding and managing your own security responsibilities is insufficient and insecure. B. While risk reports and cyber insurance are useful for risk management, they do not help you determine the division of security responsibilities in a cloud deployment. C. Reading release notes helps you stay informed about new services but does not define the fundamental boundaries of security responsibility between you and Google.
Your organization operates a hybrid cloud environment and has recently deployed a private artifact registry repository in Google Cloud. On-premises developers cannot resolve the artifact registry hostname and therefore cannot push or pull artifacts. You've verified the following. Connectivity to Google Cloud is established by Cloud VPN or Cloud Interconnect. No custom DNS configurations exist on-premises. There is no route to the internet from the on-premises network. You need to identify the cause and enable the developers to push and pull artifacts. What is likely causing the issue and what should you do to fix the issue? The options are: Option A, on-premises DNS servers lack the necessary records to resolve private Google API domains. Create DNS records for restricted.googleapis.com or private.googleapis.com pointing to Google's published IP ranges. Option B, developers must be granted the Artifact Registry Writer IAM role. Grant the relevant developer group this role. Option C, private Google access is not enabled for the subnet hosting the Artifact Registry. Enable private Google access for the appropriate subnet. Option D, Artifact Registry requires external HTTP/HTTPS access. Create a new firewall rule allowing ingress traffic on ports 80 and 443 from the developer's IP ranges.
To arrive at the correct answer, we focus on the keywords: hybrid cloud environment, private artifact registry repository, on-premises developers cannot resolve the artifact registry hostname, no custom DNS configurations exist on-premises, no route to the internet from the on-premises network.
The correct answer is option A. On-premises DNS servers lack the necessary records to resolve private Google API domains. Create DNS records for restricted.googleapis.com or private.googleapis.com pointing to Google's published IP ranges.
Why is this correct? A. On-premises systems need to resolve Google API hostnames to private IPs. Without custom DNS configurations pointing star.googleapis.com, like restricted.googleapis.com, to Google's published IP ranges, the names cannot be resolved without internet access. Why are the others incorrect? B. IAM roles do not resolve DNS hostname issues. While necessary for authorization, the developers are failing at the name resolution stage before authentication even happens. C. Artifact Registry is a managed service, not hosted in a customer VPC subnet. Additionally, the issue explicitly states the problem is DNS resolution, which private Google access alone on a subnet does not fix for on-premises clients. D. Artifact Registry doesn't require external HTTP/HTTPS access when routing via Cloud VPN. Furthermore, a firewall rule will not fix an underlying DNS name resolution failure.
Your organization has an application hosted in Cloud Run. You must control access to the application by using Cloud Identity Aware Proxy, IAP. With these requirements, only users from the app dev group may have access. Access must be restricted to internal network IP addresses. What should you do? The options are: Option A, deploy a VPN gateway and instruct the app dev group to connect to the company network before accessing the application. Option B, create an access level that includes conditions for internal IP address ranges and app dev groups. Apply this access level to the application's IAP policy. Option C, configure firewall rules to limit access to IAP based on the app dev group and source IP addresses. Option D, configure IAP to enforce multi-factor authentication, MFA, for all users and use network intrusion detection systems, NIDS, to block unauthorized access attempts.
To arrive at the correct answer, we focus on the keywords Cloud Run, Control Access, Cloud Identity Aware Proxy, IAP, AppDev Group, Internal Network IP addresses.
The correct answer is option B. Create an access level that includes conditions for internal IP address ranges and AppDev groups. Apply this access level to the application's IAP policy.
Why is this correct? B. Access Context Manager allows creating an access level with conditions for both internal IP address ranges and specific user groups, AppDev. Applying this access level to the IAP policy perfectly satisfies all requirements. Why are the others incorrect? A. Deploying a VPN does not natively integrate with IAP to enforce the required group-based access controls. C. Traditional VPC firewall rules operate at the network layer and cannot filter traffic based on identity groups like AppDev. D. Enforcing MFA and NIDS does not address the specific requirements of restricting access to internal IPs and the AppDev group.
You just implemented a secure web proxy instance on Google Cloud for your organization. You were able to reach the internet when you tested this configuration on your test instance. However, developers cannot access the allowed URLs on the secure web proxy instance from their Linux instance on Google Cloud. You want to solve this problem with developers. What should you do? The options are: Option A. Configure a Cloud NAT gateway to enable internet access from the developer instance subnet. Option B. Ensure that the developers have restarted their instance and HTTP service is enabled. Option C. Ensure that the developers have explicitly configured the proxy address on their instance. Option D. Configure a firewall rule to allow HTTP/S from the developer instance.
To arrive at the correct answer, we focus on the keywords implemented a secure web proxy instance. Developers cannot access the allowed URLs on the secure web proxy instance from their Linux instance. What should you do?
The correct answer is option C. Ensure that the developers have explicitly configured the proxy address on their instance.
Why is this correct? C. Secure web proxy operates as an explicit proxy. Therefore, client workloads, such as the developer's Linux instances, must be explicitly configured to forward their HTTP/S traffic to the proxy's IP address and port. Why are the others incorrect? A. Cloud NAT provides general outbound internet access but does not direct traffic to the secure web proxy. The proxy itself is intended to handle the outbound connections for allowed URLs. B. Restarting the instance or enabling an HTTP service does not address the missing explicit proxy configuration required on the client side to route traffic through the secure web proxy. D. While a firewall rule allowing traffic to the proxy is required, the test instance worked, implying network paths might be open. Regardless, clients still require explicit configuration to use the proxy.
You have just created a new log bucket to replace the _default log bucket. You want to route all log entries that are currently routed to the _default log bucket to this new log bucket in the most efficient manner. What should you do? The options are: Option A. Create exclusion filters for the _default sink to prevent it from receiving new logs. Create a user-defined sink and select the new log bucket as the sink destination. Option B. Disable the _default sink. Create a user-defined sink and select the new log bucket as the sink destination. Option C. Create a user-defined sink with inclusion filters copied from the _default sink. Select the new log bucket as the sink destination. Option D. Edit the _default sink and select the new log bucket as the sink destination.
To arrive at the correct answer, we focus on the keywords new log bucket to replace the _default log bucket, route all log entries, most efficient manner.
The correct answer is option D. Edit the _default sink and select the new log bucket as the sink destination.
Why is this correct? D. Editing the _default sink's destination directly to the new log bucket is the most efficient approach. It reuses the existing sink and avoids the overhead of creating and managing new user-defined sinks. Why are the others incorrect? A. Creating exclusion filters and a new user-defined sink introduces unnecessary complexity and administrative overhead compared to simply modifying the destination of the existing _default sink. B. Disabling the _default sink and creating a new one requires managing an additional resource. Directly editing the existing _default sink is more straightforward and efficient. C. Manually copying inclusion filters to a newly created user-defined sink is inefficient when you can directly update the destination of the existing _default sink.
You are responsible for a set of cloud functions running on your organization's Google Cloud environment. During the last annual security review, secrets were identified in environment variables of some of these cloud functions. You must ensure that secrets are identified in a timely manner. What should you do? The options are: Option A, implement regular peer reviews to assess the environment variables and identify secrets in your cloud functions. Raise a security incident if secrets are discovered. Option B, implement a cloud function that scans the environment variables multiple times a day and creates a finding in Security Command Center if secrets are discovered. Option C, use sensitive data protection to scan the environment variables multiple times per day and create a finding in Security Command Center if secrets are discovered. Option D, integrate dynamic application security testing into the CI/CD pipeline that scans the application code for the cloud functions. Fail the build process if secrets are discovered.
To arrive at the correct answer, we focus on the keywords: cloud functions, secrets were identified in environment variables, ensure that secrets are identified in a timely manner.
The correct answer is option C, use sensitive data protection to scan the environment variables multiple times per day, and create a finding in Security Command Center if secrets are discovered.
Why is this correct? C. Sensitive data protection is a fully managed service specifically designed to discover and classify sensitive data. It integrates natively with Security Command Center to automate the continuous scanning of environment variables and report findings in a timely manner. Why are the others incorrect? A. Relying on manual peer reviews is not scalable, continuous, or automated, making it an unreliable and slow method for identifying exposed secrets. B. Developing and maintaining a custom cloud function for scanning introduces unnecessary operational overhead and complexity when a fully managed Google Cloud service already exists for this exact purpose. D. Dynamic application security testing, DAST, interacts with a running web application to find vulnerabilities like XSS or SQL injection. It is the wrong tool for scanning environment variables or code for secrets.
Your organization wants developing a new SaaS application on Google Cloud. Stringent compliance standards require visibility into privileged account activity and potentially unauthorized changes and misconfigurations to the application's infrastructure. You need to monitor administrative actions, log changes to IAM roles and permissions, and be able to trace potentially unauthorized configuration changes. What should you do? The options are: Option A, create log syncs to cloud storage for long-term retention. Set up log-based alerts in cloud logging based on relevant log types. Enable VPC flow logs for network visibility. Option B, deploy Cloud IDS and activate firewall rules logging. Create a custom dashboard in Security Command Center to visualize potential intrusion attempts. Option C, detect sensitive administrative actions by using cloud logging with custom filters. Enable VPC flow logs with BigQuery exports for rapid analysis of network traffic patterns. Option D, enable event threat detection and security health analytics in Security Command Center. Set up detailed logging for IAM-related activity and relevant project resources by deploying cloud audit logs.
To arrive at the correct answer, we focus on the keywords: visibility into privileged account activity, unauthorized changes and misconfigurations, monitor administrative actions, log changes to IAM roles and permissions, trace potentially unauthorized configuration changes.
The correct answer is option D, Enable event threat detection and security health analytics in Security Command Center. Set up detailed logging for IAM-related activity and relevant project resources by deploying Cloud Audit logs.
Why is this correct? D. Event threat detection and security health analytics detect threats and misconfigurations. Cloud Audit logs natively record administrative actions and IAM role changes, providing the required visibility into privileged activity and configuration modifications. Why are the others incorrect? A. VPC flow logs monitor network traffic, not administrative actions or IAM changes. Log-based alerts alone do not directly analyze misconfigurations as effectively as security health analytics. B. Cloud IDS and firewall rules logging focus on network intrusion detection and traffic monitoring, not tracking IAM changes, administrative actions, or resource misconfigurations. Why are the others incorrect? C. VPC flow logs analyze network traffic, not administrative actions. Relying on custom cloud logging filters is less effective than leveraging Cloud Audit logs and SCC for comprehensive IAM and configuration visibility.
Your application development team is releasing a new critical feature. To complete their final testing, they requested 10,000 real transaction records. The new feature includes format checking on the primary account number, PAN, of a credit card. You must support the request and minimize the risk of unintended personally identifiable information, PII, exposure. What should you do? The options are: Option A, run the new application by using confidential computing to ensure PII and card PAN is encrypted in use. Option B, scan and redact PII from the records by using the Cloud Data Loss Prevention API. Perform format preserving encryption on the card PAN. Option C, encrypt the records by using Cloud Key Management Service to protect the PII and card PAN. Option D, build a tool to replace the card PAN and PII fields with randomly generated values.
To arrive at the correct answer, we focus on the keywords, real transaction records, format checking on the primary account number, PAN, minimize the risk of unintended personally identifiable information, PII, exposure.
The correct answer is option B, scan and redact PII from the records by using the Cloud Data Loss Prevention API. Perform format preserving encryption on the card PAN.
Why is this correct? B. Cloud Data Loss Prevention, DLP, allows scanning and redacting PII. Format preserving encryption maintains the original data format, which is essential to support the requested format checking on the PAN while minimizing PII exposure. Why are the others incorrect? A. Confidential computing protects data in use, but standard encryption breaks the original format of the PAN, causing the application's format checking feature to fail during testing. C. Cloud Key Management Service encrypts data at rest or in transit. This alters the data format, which prevents the application from properly testing the PAN format checking feature. D. Building a custom tool introduces unnecessary operational overhead and potential security vulnerabilities, whereas managed services like Cloud DLP are designed specifically for this use case.
You work for a banking organization. You are migrating sensitive customer data to Google Cloud that is currently encrypted at rest while on premises. There are strict regulatory requirements when moving sensitive data to the cloud. Independent of the cloud service provider, you must be able to audit key usage and be able to deny certain types of decrypt requests. You must choose an encryption strategy that will ensure robust security and compliance with the regulations. What should you do? The options are: Option A, utilize Google default encryption and Cloud IAM to keep the keys within your organization's control. Option B, implement Cloud External Key Manager, Cloud KMS, with access approval, to integrate with your existing on-premises key management solution. Option C, implement Cloud External Key Manager, Cloud KMS, with key access justifications to integrate with your existing on-premises key management solution. Option D, utilize Customer Managed Encryption Keys, CMEK, created in a dedicated Google Compute Engine instance with confidential compute encryption, under your organization's control.
To arrive at the correct answer, we focus on the keywords: independent of the cloud service provider, audit key usage, deny certain types of decrypt requests.
The correct answer is option C, implement Cloud External Key Manager, Cloud KMS, with key access justifications to integrate with your existing on-premises key management solution.
Why is this correct? C. Cloud KMS keeps keys independent of Google. Key access justifications, KAJ, provide a reason for every request, enabling you to audit usage and create policies that automatically deny specific types of decrypt requests. Why are the others incorrect? A. Google default encryption keeps keys under Google's control, violating the requirement to manage keys independently of the cloud provider. It also lacks the capability to deny specific decrypt requests. B. While Cloud KMS keeps keys external, access approval only gates Google support access. It does not provide the justification for each decrypt request needed to programmatically deny specific access attempts. D. CMEK stores keys within Cloud KMS, violating the requirement to maintain key control independently of the cloud provider. It also does not natively support denying specific decrypt requests based on justifications.
Your organization is developing an application that will have both corporate and public end users. You want to centrally manage those customers' identities and authorizations. Corporate end users must access the application by using their corporate user and domain name. What should you do? The options are: Option A, add the corporate and public end user domains to domain restricted sharing on the organization. Option B, federate the customer's identity provider, IDP, with Workforce Identity Federation in your applications project. Option C, do nothing. Google Workspace Identities will allow you to filter personal accounts and disable their access. Option D, use a customer identity and access management tool, CIAM, like Identity Platform.
To arrive at the correct answer, we focus on the keywords: both corporate and public end users, centrally manage those customers' identities and authorizations, corporate user and domain name.
Correct answer is option D, use a customer identity and access management tool, CIAM, like Identity Platform.
Why is this correct? D. Identity Platform is a customer identity and access management (CIAM) tool designed specifically to add identity and access management to applications, supporting multiple identity providers including both corporate (SAML/OIDC) and public end-user identities centrally. Why are the others incorrect? A. Domain restricted sharing is an organization policy constraint used to restrict Google Cloud resource sharing based on domains, not a tool for managing custom application end-user identities. B. Workforce Identity Federation is used to grant external workforce identities access to Google Cloud resources, APIs, VMs, not for centrally managing authentication for an application's end users. Why are the others incorrect? C. Google Workspace alone is designed for internal employee identity management and does not natively manage public consumer identities or provide a comprehensive CIAM solution for applications.
You work for an organization that handles sensitive customer data. You must secure a series of Google Cloud storage buckets housing this data and meet these requirements. Multiple teams need varying access levels, some read-only, some read-write. Data must be protected in storage and at rest. It's critical to track file changes and audit access for compliance purposes. For compliance purposes, the organization must have control over the encryption keys. What should you do? The options are: Option A, create IAM groups for each team and manage permissions at the group level. Employ server-side encryption and object versioning by Google Cloud Storage. Configure cloud monitoring tools to alert on anomalous data access patterns. Option B, set individual permissions for each team and apply access control lists, ACLs, to each bucket and file. Enforce TLS encryption for file transfers. Enable object versioning and cloud audit logs for the storage buckets. Option C. Use predefined IAM roles tailored to each team's access needs, such as Storage Object Viewer and Storage Object User. Utilize customer-supplied encryption keys, CSEK, and enforce TLS encryption. Turn on both object versioning and cloud audit logs for the storage buckets. Option D. Assign IAM permissions for all teams at the object level. Implement third-party software to encrypt data at rest. Track data access by using network logs.
To arrive at the correct answer, we focus on the keywords, varying access levels, some read-only, some read-write, protected in storage and at rest, track file changes, audit access for compliance purposes, control over the encryption keys.
The correct answer is option C. Use predefined IAM roles tailored to each team's access needs, such as Storage Object Viewer and Storage Object User. Utilize customer-supplied encryption keys, CSEK, and enforce TLS encryption. Turn on both object versioning and cloud audit logs for the storage buckets.
Why is this correct? C. Predefined IAM roles easily manage varying access. Customer-supplied encryption keys, CSEK, fulfill the requirement for the organization to control encryption keys. Object versioning tracks file changes, and cloud audit logs handle access auditing. Why are the others incorrect? A. Default server-side encryption is managed by Google Cloud, which fails to meet the requirement that the organization must have control over the encryption keys. B. Managing individual permissions and ACLs per file is complex and unscalable. Additionally, it does not specify organizational control over encryption keys. D. Assigning object-level permissions is not a scalable practice. Network logs are insufficient for granular data access auditing, and third-party encryption adds unnecessary complexity.
You are implementing communications restrictions for specific services in your Google Cloud organization. Your data analytics team works in a dedicated folder. You need to ensure that access to BigQuery is controlled for that folder and its projects. The data analytics team must be able to control the restrictions only at the folder level. What should you do? The options are: Option A. Create an organization-level access policy with a service perimeter to restrict BigQuery access. Assign the data analytics team the Access Context Manager editor role on the access policy to allow the team to configure the access policy. Option B. Create a scoped policy on the folder with a service perimeter to restrict BigQuery access. Assign the data analytics team the Access Context Manager editor role on the scoped policy to allow the team to configure the scoped policy. Option C. Define a hierarchical firewall policy on the folder to deny BigQuery access. Assign the data analytics team the Compute Organization Firewall Policy admin role to allow the team to configure rules for the firewall policy. Option D. Enforce the Restrict Resource Service Usage Organization policy constraint on the folder to restrict BigQuery access. Assign the data analytics team the Organization Policy Administrator role to allow the team to manage exclusions within the folder.
To arrive at the correct answer, we focus on the keywords, communications restrictions for specific services, dedicated folder, access to BigQuery is controlled for that folder, control the restrictions only at the folder level.
The correct answer is option B. Create a scoped policy on the folder with a service perimeter to restrict BigQuery access. Assign the data analytics team the Access Context Manager editor role on the scoped policy to allow the team to configure the scoped policy.
Why is this correct? B. VPC Service Controls scoped policies enable delegating perimeter administration to the folder level. Creating a scoped policy on the folder and assigning the Access Context Manager editor role allows the team to securely control BigQuery access strictly within their folder without affecting the rest of the organization. Why are the others incorrect? A. Creating an organization-level access policy would grant the data analytics team the ability to modify perimeter controls across the entire organization, which violates the requirement to restrict their control to only their folder. C. Hierarchical firewall policies apply to VPC networks and control IP-based traffic, not API-level access to Google Cloud managed services like BigQuery. D. Organization policy constraints manage resource configuration and API enablement, but cannot implement granular access control perimeters or network-based communication restrictions for BigQuery.